In this lecture, we will be seeing another example where we will be proving that a given language is not regular using pumping lemma. I have discussed the steps in the last 2 lectures in detail, so in this I will not be discussing the steps in detail anymore. Okay, so let's see the language that we are given. The language that we are given is this one, A, which is equal to YY for all Y belongs to 0, 1 star. 0, 1 star means the set of all strings that can be formed using the symbols 0 and 1. So let us first try to understand why this language is not regular. So this language is of the form YY, which means that the first part of the string should be same as the second part of the string. So any strings whose first half is equal to the second half will lie in this language. For example, let me take this first Y to be 0, 1. So if my first Y is 0, 1, then the second Y should also be 0, 1. So we see that the first half of the string is equal to the second half. That is the language strings that will be accepted by this language. Now why this is not regular is because in order to repeat the first part exactly in the second part, you need to remember what was the first part. And in order to remember what was the first part, you need to have memory. So only if you store the first part in memory, then you can repeat it exactly in the second part. But we know that finite state machines has a very limited memory, and this kind of things cannot be stored in its memory. So since this kind of language here requires memory, it cannot be designed using finite state machines. And if it cannot be designed using finite state machines, that means it is not a regular language. So I hope you understand why this is not regular. Now that is a theoretical knowledge that we have, but we need to prove it using pumping lemma. Okay, so let's see how we can do it. So for the proof, what we will do is we will first assume that A is regular. So assume that A is regular. So this is how we do it. We will first assume that it is regular, and from the steps that we will follow, we will derive at a conclusion that will contradict with our assumption, and from the contradiction we will prove that it is not regular. So first we assume that A is regular. So we already discussed, if A is a regular language, then it must have a pumping length. It must have a pumping length, and let me call that pumping length to be P in this case. Alright, so I call my pumping length P, and now what I'll do is I will choose a string S from this language. Okay, and I can choose any string. Now let me choose the string like this. For example, 0 raised to P 1, 0 raised to P 1, where P is my pumping length. Now we see that this means that the string contains P number of zeros followed by a 1, and then again P number of zeros followed by a 1. So we see that the first half and the second half are exactly similar. So it lies in this language A. Okay, so once you have chosen this string S, the next thing that you have to do is you have to divide this S into 3 parts: X, Y, and Z. Now that is what we have to do. So as we divide it into 3 parts, X, Y, and Z, let me take an example. Let's say that for that example, I'll say that my pumping length P is equal to 7. Okay, so if pumping length P is equal to 7, then let me form a string using this S and P whose value is equal to 7. So I will have 1, 2, 3, 4, 5, 6, 7 zeros, and then there is a 1, and again 1, 2, 3, 4, 5, 6, 7 followed by a 1. Okay, so this is the string that we have, and now I will divide this into X, Y, and Z. So the most important is our Y. So let me say that this 4 zeros over here, this is my Y, and these 2 zeros, this is my X, and from these zeros till the end the remaining part is Z. Okay, so we have divided into X, Y, and Z. Now I will take this one, x y raised to I z, and let me take my I is equal to 2, so I will have x y raised to 2 z. And we already discussed in the previous lectures that if this language is regular, then x y raised to I z should also lie in the language that is given. So let us make our string in this way. What is x? X is 0 0 0 0. And what is y? Y contains 1 2 3 4 zeros. 1 2 3 4, and it is y square, so we have to repeat y once more. So 1 2 3 4 more zeros, and then z. Z is 0 1 0 1 followed by 7 zeros and then 1. 1 2 3 4 5 6 7 and then 1. Okay, so this is the string that we obtained. Now let us see whether this string lies in our language A or not. So here we see that the first half of the string is not equal to the second half of the string. So here before this one over here we have 1 2 3 4 5 6 7 8 9 10 11 zeros, and before this one there are only 7 zeros. So this does not follow the pattern YY, so it is not of this form. So this does not lie in the language A. So from this we see that this string does not lie in our language A. And there were two more conditions, if you remember. Another condition was that the length of y should be greater than 0. So the length of y, it is greater than 0, it is correct. And then also there is another condition which says that the length of x and y together must be less than or equal to p, and in our case this p is equal to 7. So here if you check in this string, you see that what is the length of x and y together? 1 2 3 4 5 6. Alright, so it satisfies. And one thing you have to note is that it should be less than or equal to 7. So if I choose my y in such a way that the y lies ahead of this 1, then this condition will not be satisfied. The length of x and y together will become greater than or equal to 7, but 7 is my pumping length, and that is not allowed. So when you divide this into x, y and z, you should make sure that for this particular example y should contain only zeros. If it contains 1, then this condition will fail. Okay, so we divided it in this way, and we saw that when we take x y square z, the string that we obtain does not lie in the language A. So hence we see that it cannot be pumped, and so it contradicts with our assumption that A is regular. So that is a contradiction to our assumption, and hence we can say that A is not regular because we got a contradiction. So I hope that was clear to you. This is how you prove that a language is not regular using pumping lemma. So thank you for watching, and see you in the next one.